In this video, I want to talk about how we can perform voltage and current division. And to do that, we will use resistor networks. And we'll just try to make sense of what resistors are and what resistor networks are and how we can perform voltage and current division. Now, if you remember the context of our course, what we are thinking about is electronic circuit design, and we are using what we are calling the signal processing approach to doing that. And in that context, we start off with a signal transformation, right? So you have an input and you want to change that input in some way, and you have a signal transformation that you have in mind which you want your circuit to do. So if you have this transformation, the next step that we want to do is we want to break this transformation into a series of smaller transformations. Okay? And these series of transformations, what you want to do is you want to look into your bag, and this is your bag of electronic circuits, and you want to see whether you can find an electronic circuit in your bag that can do each of these transformations. Okay, so for each of these transformations, what you do is you find an electronic circuit that does the transformation. And this process may go back and forth. Like you have a transformation and you find a circuit, that's well and good, but sometimes you may find a circuit that does slightly different transformations, and you may have to kind of change your transformation then a little bit and then match it to the circuit. Okay, so once you get this, you put all these circuits together. You put the circuits together and you have your electronic circuit system. So put the circuits together. And now putting this together would involve knowing how each of these circuits fit together and whether one circuit influences the other and so on and so forth. Okay, so this is the context in which we are working. So what I want to start off with is today is trying to give you at least one block in your electronic circuit bag, and that block is a voltage division block. And of course, along with it, I also want to talk about a current division block. So if you have a voltage or if you have a current, how do you divide it? So you could think of it like this. Suppose you have an electronic circuit here, and to this electronic circuit we give an input, and let's call that input V in, and the circuit gives you an output which let's say we call V out, right? So I want to tell you about a circuit that gives you a V out which is equal to V in over A, where A is a constant number. So that's voltage division. And in a similar way, I want to also give you a circuit that when it takes a current input, gives you a current output that is equal to the input current divided by a constant value. So this is what I mean by voltage or current division. I thought it would be interesting to just talk about a few applications, two applications of voltage division and current division, so that it just gives you a sense of where we actually use it. Okay, so think about a electrical device. Think about an electrical device like an iron or a hair dryer or something of that kind. Okay, so here's an electrical device, and this electrical device is plugged into a power supply, which I'll draw like this, and this power supply is 120 volts, and the power supply goes to the electronic device, and there's the casing, and it goes through the casing into a circuit that is internal, which is put in inside the casing. Okay, now if there is a human being around, and let's say here's a person here, and he's touching the casing, he's not going to be affected by it because the casing is protecting him from actually touching the inside of the circuit where the 120 volts is. Okay, now think about the case when this person's feet is, let's say, touching the ground. This is a symbol for the ground. Now think about what happens when there is a fault in this in this device, and the fault takes a specific form. And what happens is that this 120 volts voltage is basically, by some mistake, this wire gets connected to the casing. Okay, so then what happens is if the wire gets connected to the casing, then the voltage of this entire casing becomes 120 volts, right? Or in other words, we say that the casing has become live, which means that now this person who's here, he's not just touching a casing which is electrically neutral, but he's touching 120 volts. So what can happen now because of this is that a current can start flowing from the power supply through the casing, through the human being, back to ground. Okay, and of course this is an electrical shock. Okay, so to prevent this, what we usually do is we ground the casing. So that's a safety measure that we do, and therefore in most electrical equipment you would have a three-pronged plug that plugs into the socket on your wall, right? So one of those plugs is a ground plug, and we'll just talk about why that ground plug is absolutely important. Now, if there is a ground connection like this, then what happens at this point is that some of the current goes through the human being, as we already saw, and some of the current goes like this to ground. So there is a current division, right? So the current that is flowing here, I, is divided into two currents. Let's say I body, and let's call it I ground. Okay, and if most of the current goes through the ground, okay, it goes through the ground, then we have a situation where very little current is passing through the human body, and therefore this person is safe. But if most of the current actually flows through the body, then we may have a place where the person gets a shock, and in some cases it may be fatal, right? And therefore it's absolutely important to have this ground connected. And many times what we do is we take this three-pronged plug and connect it to some kind of an extension cord which has got only two plugs and plug it into the wall. And that's a very bad idea, because in that case, what happens is we do not then have a ground like this. And if you don't have a ground, what will happen? All the current flows through the body, and there's a very large chance that you can get a real electrical shock. So this is a case where this current I is being divided into two parts, I body and I ground. And I thought this is a good example of an application of current division, where we use this idea of current division to make sure that this person is safe when he is using the electrical device. Let me take another example and show you how one application where voltage division plays a role. Okay, so let's say you have, okay, let me just switch on my pen, and let's say we have a voltage here. Okay, and let's say it's something around 10 volts, and I put two resistors, and I know that you don't really know what resistors are right now. We've not really talked about it, but we'll get there in a moment. Okay, and this resistor is changing, and let's say it changes in response to temperature, and that would be a sensor which is called a thermistor. A thermistor is basically a thermally sensitive resistor, or there are many other sensors which change their resistance based on the parameter or that they are sensing. So for example, you could have force sensitive resistors that change their resistance as force is applied on it. You could have resistors that change their resistance depending on the humidity of the environment, and so on and so forth. So this resistance change can be used as sensors. Okay, so let's call this as R, and let's call this as R sensor. Okay, and we take the output of this circuit from here. Now this output is going to depend on the value of the resistance that we have connected here of this sensor, and as this sensor changes its value, the output value is going to change, and that enables us to measure the quantity that we are trying to measure, right? So let me just summarize. So we are using a sensor which in response to a physical quantity changes its resistance, and this resistance can be converted into a voltage by this kind of a circuit. And this is basically a voltage division circuit. So it divides 10 volts into two parts, or into some voltage called VO, which is the output voltage. But this division depends on these resistances. And as this resistance changes, this output changes. So there's a very simple application of voltage division. So anyway, so we've talked about voltage and current division. In the next video, we'll look at how resistors, what are resistors first of all, and how resistors can actually achieve voltage and current division.